Alright, my name is Scott Riddle, and this is for Programming Languages, Computer Science 326 in the spring of 2025. And my project was assignment operators, so these include plus equals, minus equals, times equals, divide equals. And some examples of this would be like x plus equals 1. So what this would do is it would take the value of x, add 1 to it, and then assign that value back to x. These operators also work with array indexes, so it would take the value at this array index, divide it by 3, and then assign that value back to that index. It also works with string concatenation, so this would be a string, and you could do plus equals another string, so that would concatenate this string on the end of this string. So the example that I developed is a simple game. It has a player struct, which has name, health, stamina, and gold. And basically, the player goes through different actions. They could either attack, they can drink a health potion, they can drink a stamina potion, they can loot the area, or they can run away. And each of these actions use the assignment operators to manipulate their stats in certain ways. So say if they attack, their stamina gets decreased by 40 using the minus equals assignment operator, their health gets decreased by 20, and their gold gets decreased by 5. Similarly, if they wanted to drink a stamina potion, they increase their stamina by 20 using the plus equals assignment operator, but they minus their health by 20 using the minus equals assignment operator. So let's see this in action. Alright, so let's see the game. Alright, so first we can input our name, and we can also input our last name, so this utilizes the string concatenation with the plus equals assignment operator. So I'll put Riddle, because that's my last name. And my greatest enemy has to be Jack Kabil. Spell his name right. Alright, so we can see our stats right away, and we can take our first move, so I think I'm going to attack Jack right off the bat. And so we see that Jack's health got decreased down to 80, and since it cost 40 stamina for me, I lost 40, and now my stamina's at 60. So I don't like that, so I'm going to take a stamina potion. Okay, let's see. I took a stamina potion, so that healed me 20 stamina, but while I was refueling, he hit me for 20, so my health went down to 80. So I think I'm going to hit Jack Kabil again. Boom, his health's now at 60. Perfect. And I'm going to hit him again because I have enough stamina. So now my stamina's completely out. But Jack's at 40, so that's good. And I have 10 gold. So I think what I'm gonna take a stamina potion. And oh, it looks like Jack hit me again for 20, so my health went down. I gotta take another stamina potion because I need enough stamina to attack. So I have 40 stamina now. Jack's also at 40 health, so I'm gonna take a health potion. Actually, I'm not really comfortable with how healthy I am. Alright, looks like I got my health back up a little bit. You know, while I'm at it, I'm gonna loot the area. Cool, I found 5 gold, but Jack Kabil roundhouse kicked me in the face for 20 points, so I'm back down to 40, which is perfect. Actually, it's not. I don't like that at all. So I'm gonna attack Jack again because I really didn't like that. Looks like I'm at 40. He's at 20, so he's just a one hit at this point. So I really got to get my stamina up. So I'm gonna take a stamina potion. And I have a feeling that he's going to hit me again if I take another one. So I'm going to take a health potion. Boom. Take a stamina potion. Nice. I have just enough stamina to win the game. And when I died, I looted his corpse for all his gold. So I got all his gold too, which is perfect. Alright, now let's see how I implemented this. So first, I reasoned that, okay, if I want to make some assignment operators, I got to add more tokens. So I added the plus equals, minus equals, times equals, and divide equal tokens. And then I subsequently checked for those tokens in the lexer. So originally it would just check for plus, and then it would return the plus token. But then I peeked and see if it was an equal. And then I'd have to read past the equal and return the plus equals. And I did that similarly for the other assignment operators. And for the tests, I just firstly test each assignment operator that it was correctly lexed, and then just made sure it worked in a statement. And then I moved on to the AST. Initially, I was planning on making it an entirely separate class for assignment operators, but I quickly learned that I'd have to read through the entire L value to see if it was an assignment statement or a sign op statement. So I opted instead just to add this line to a sign statement, just add an assign op instead of nothing there originally. And so to parse that, just with the syntax, I had to match on any of the assignment operators, and if it wasn't, then I'd throw an error. And similarly for the AST parser, I would do the same thing, but also I would set the assignment statement's assign op to the current token and then advance through it to get to the expression. And for the syntax tests, I just basically did just basic syntax for assignment operators just to see if it worked, and it seemed to work fine. This one should have failed because this is not a correct L value, so I just wanted to make sure that still worked with assignment statements. And for the AST tests, I made sure that these were all parsed correctly. I made sure that paths worked with my new assignment statement constructs. I made sure that array accesses were able to be parsed. And I made sure that more complex paths, including array access, were able to be parsed. And print visitor is pretty easy. All I had to do was just check which assignment operator it was and then print the correct thing instead of just printing an equal sign. For the semantic checker, I opted to say that both sides of the assignment operator had to be the same type, which was consistent with what it already was. And so here I'm implementing the concatenation on strings. So we had to make sure that if it was a string, that it wasn't any of these operators. It could only be the plus equals operator and the assignment operator itself. On bools, you can't do any of the assignment ops because you can't do math on bools, so it has to be just the assignment. And then you can, with a normal assign, you can assign to null, but since you can't do math on null values, you can't do any of my new assignment operators when the right-hand side is a null val. And then for the semantic checker tests, I just went through just basic. These expressions these statements should check fine, which they did. This is for string concatenation. This works fine. The type mismatch, so var x, this is an int, and I'm trying to add a double to it, so this throws an exception. Similarly, this does an assignment operator on a bool, even though this right-hand side is the same type as this, because this is a mathematical operation, you can't do that on a bool. Similarly, with a string, you can't do minus equals, times equals, or divide equals. You can only do plus equals to concatenate. And you can't do anything on a null, except for just a normal assign. My code generator was a little bit more interesting. I had to push more things. So for example, let's just go down. This would be for just just a single variable. So first I check if it's just a normal assign. I just push the value and store it in the variable. But if it's one of my new assign ops, then I have to load the variable, push the right-hand side, perform the operation on those two values, and then restore the result in the variable. And it's similar for an array access, just a single array access, not a path. So I check if it's an assign, and if it is, then I just push the value to assign to the left-hand side. But if it's not, then I have to get the value at the index, get the right-hand side value, push it, perform the operation, and then set the index. Where it got complicated was in path expressions. I realized that I needed a certain setup for set I. Originally it was it would pop the value, then the index, then the OID. But for for a path ending in a variable in an array access, I needed to pop the index first, then pop the value, then pop the OID to set I. And so I added this flag to set I, swap index and value, and it's true here. So you can see here I modified the VM instruction with this flag. And in the VM, I basically just swapped x and y. X is normally a value and y is normally the index, but if this flag is set, then I swap them. And here I just make sure all that works fine still. And so, yep, these are just basic assignment operators and they seem to work fine. These are the ones on doubles and they also work fine. Java does weird stuff with doubles, but at least it's predictable every time. This does string concatenation, so this actually works. Prints hello world. I made sure that it works on array accesses, which it does. It works on a simple variable path, and it works on a path ending in an array, and it works on a very complex path that has both fields and arrays in it. Yeah, so that's pretty much it. I've completed everything for this extension except for the semantic checker that checks for paths. Variable paths don't type check, only simple variables. So this is an example that wouldn't type check. This would not throw an error because paths are not type checked. And if I had more time, basically I'd just complete the semantic checker, fully flesh it out, and make sure it checks paths. But other than that, everything works. So yeah, thank you. That was my extension.